Okay, so to finish this one, where we had left off was we were saying that 2, 3, 4, 5 had replaced our 3, 4, 5 and our 2. Okay, and our 3, 4, 5 and our 2 are in parallel. So in parallel, the voltage should be the same. So V2 should be equal to V345, should be equal to V2345, which we found was 10 volts. So 345 should be 10 volts. That will be 10 over 12, which is 5 over 6 amps. And V2 should be equal to 10 volts as well, which will be 10 over 12, or 5 over 6 amps. Okay, so we've completed this circuit. Now we step back, and 3, 4, 5 replaced our 3, 4, and our 5. And our 3, 4, and our 5 are in series, and in series, the current is the same. So I34 should be equal to I5 should be equal to I345. So this is going to be 5 over 6 of an amp, and this is going to be 5 over 6 of an amp. When we multiply by 6, we get 5 volts and 5 volts. We finished that one. So now we step back again and look at 3, 4, and 3, 4 is in parallel. Our 3 is equal to R4, or in parallel, V3 should be equal to V4, should be equal to V34. So V34 was 5 volts, and so V3 should be 5 volts, V4 should be 5 volts, so this will be 9 over 5 amps, and this one will be, yeah, that's 5 over 9 amps, and 5 over 18 amps, and we are done. Okay, so that's number 34. I'd also asked you to look at number 29, and the only tough thing about 29 is they don't actually draw it for you, and I thought it mightn't be a bad thing for you to see if you can draw it. So 29 says a load R1 is connected in series with two loads R2 and 3, which are connected in parallel with each other. If the potential difference of the power supply is 180 volts. Okay, so you have a power supply, you have R1, and then it says R1 is connected to R2 and R3, which are in parallel with each other. And that's it in the circuit. Okay, so it tells us our V total is 180 volts, and then it says the R's are 25, 30, and 6, respectively. So 25 ohms, R2 is 30 ohms, and R3 is 6 ohms. So in the first step, you would have to put R2 and R3 together. And so power supply, R1, R2, 3, R1 is 25 ohms, and R2, 3 you have to get by doing 1 over. So 1 over R2, 3, 1 over R2, 1 over R3. So 1 over R2, 3, 1 over 30, plus 1 over 6, which is 5 over 30. 5 over 30 plus 1 over 30 is 6 over 30. Reduces to 1/5, so R2, 3 equals 5 ohms. And the good news is you don't have to simplify it anymore. You're done. It's now a series circuit, so your chart's going to be nice and tiny. It's going to be totals. It's going to be 1. It's going to be 2. It's going to be 3. And it's going to be 2, 3. And that's it in your chart. pretty nice after the last long ones you've done. So 2, 3 we found to be 5 ohms, 3 was 6 ohms, 2 was 30 ohms, 1 was 25 ohms, and we look at our most simplified circuit to get our total. It's in series, add them together, 25 plus 5 is 30 ohms, and our total was 180 volts. So when we divide here, we get 6 amps for our total. We have all the R's, we have our totals. So we come back to our most simplified circuit, we look at it, it's in series. In series, what's the same? It's the I's that are the same. So I1 should equal I23 should equal I total. We just found I total to be 6 amps. So I1 should be 6 amps, and 6 times 25 will be 150 volts. And then I23 should be 6 amps, and 6 times 5 is 30 volts. And they add back together, 30 and 150 gives you 180. So we step back, 2 and 3 are in parallel. In parallel, the voltage is the same, so V2 should equal V3, should equal V23. 30 volts, 30 volts, and now you can divide 1 amp, 5 amps. They add back together to give you 6 amps. You are done. All is well. Okay, so hopefully these make sense. Hopefully you're getting them. Hopefully you'll ace them on the test and on the exam. Good job.